Welcome in lecture Fact and Power Quality. In the previous lectures, it has been discussed the basic system of fact devices, basic of the STATCOM. So STATCOMs comes under the switching converter type war generator, and in the switching converter type war generator, uh, the GTOs, that is the gate turnoff, and IGBTs are used as a switching device in the STATCOM or static war generator. Static war generator is nothing but it is a similar to the synchronous motor, under-excited and over-excited. It is already explained in the converter switching converter type fact device. So this is the bus voltage. This is coupling transformer. This is the reactance, which is include the transformer leakage reactance of transformer and machine synchronous reactance. This is the synchronous motor and excitation. So definitely when the synchronous back EMF of motor, say E, this is the voltage E, is smaller than supply voltage or the bus voltage. It is called as it conditions comes under the under excitation, and motor is going to work at lagging power factor, and under such condition, the current is going to consume from system to the machine side. So we can say that it absorb reactive power. Definitely it is a inductive reactive power Q. So it consumes the reactive power. As it is a motor, because of the rotational losses and windage and frictional losses are there, it absorbs the active power also. It also absorbs the reactive power. Whereas when back EMF, the back EMF E is greater than supply voltage, it means that it is a overexcited. It is overexcited and work on leading power factor, and definitely under such condition, the direction is opposite, means it is going to supply the current to the bus, and it supplies reactive power Q, whereas as it is a motor rotating part, so it consumes the active power. So it consumes the or absorb power P. And when the voltage back EMF and is equal to the supply voltage, it is normal excitation, and under normal excitation, the power factor is unity power factor, and just it is neither supplying nor consuming the reactive power, but active power is going to consume. So this is the operation of synchronous motor. But we want static. It is okay. You can call as a synchronous condenser or compensator. It is called as a synchronous condenser and capacitor. Now, our objective to make the static synchronous one. Static. If the machine, this part is replaced by the static device or some electronic circuitry, so static synchronous compensator or condenser, it has become a STATCOM. So what is a STATCOM? STATCOM, the basic operation of STATCOM is similar to the synchronous motor, whereas the synchronous motor is replaced by a converter circuit, then it become a static STATCOM, this one. Okay. So the very first STATCOM were installed in um, some Sullivan substation in USA in 1995. So STATCOM is a shunt connected reactive power compensation device that is capable of generating and absorbing. Generating when it is supplying the reactive power. So this is the case of the generating, whereas this case is the absorbing. So static shunt compensator or STATCOM, you can call as a SSCs, a synchronous static synchronous compensator is a shunt connected reactive power compensation device that is capable of generating and absorbing the reactive power, in which the output can be varied to control the specific parameter of our electrical system or electrical power system. So in general, the solid switching converter capable of generating and absorbing independent controllable reactive power is fed from the energy source with conjunction with the energy source. So it means that in conversion, in that case, you can provide some energy storage system also. So we will see one by one. So this is the basic STATCOM is there. The motor is replaced by the, say, it is replaced by this circuit. Okay. So rest of the things are as it is. It is a coupling transformer. It is the transformer leakage reactance. So it is not an external reactance. And here the charge capacitor is there to provide the DC current to the DC to AC conversions are there, or converters are there. Now this converter circuit, two types. One is the voltage source converter, and second is the current source converter. But in practice, voltage source converters are used because it does not require any external says protection circuit, as well as economically it is benefited. So therefore we are using the voltage source converter, uh, just replacing the synchronous motor by this one. The action is same. If this voltage is greater, means V0 in this circuit, when V0 is is smaller than the supply voltage, it consume, or we have used the word absorbs reactive power. Whereas voltage V is greater than the, means converter voltage is greater than the system voltage, definitely the current in this direction, opposite direction, means it is going to supplies reactive power P. Now here, the active power does not comes into this particular circuit. But as soon as it is replaced by some energy storage system, suppose here there is some energy storage system, and now it is connected to the circuit. Definitely, it handle the active power also. So to handle the active power, one may connect the say active power also. Just we will draw a one figure over this one, so that just a minute. Okay, so say this is the system voltage. Okay, now there is a leakage or there is a coupling transformer, and a coupling transformer having some reactance. So this reactance is replaced, and there is a voltage source converter. Say this is the, in this box there's a voltage source converter, and this is the charge capacitor. First, we will take without any this one. So it is a voltage source capacitor converters is there. It may be a IGBT on GTO. So say suppose this is the voltage source converter. Voltage source converter. This voltage, say it is back EMF or E. This is system voltage, it is V, and the reactance is X, and this current is IAC, or say this is also VAC, and this is the system voltage, and here is the capacitor charge voltage. So what are the different conditions? The case one. Say case one is that the VAC it is VAC is greater than system voltage. So what would be the condition? The current flows through the reactor from converter to AC system. So here in this case, the current is going to flow from the converter to, say, current flows from converter to AC system, or the system transmission system is there, and it absorb, or you can say that here the generation will be there. So here is the generation, okay, and generation of reactive power. What is reactive? It is definitely, it is a capacitive reactive power. So it's the leading side, reactive power, and supplies. So here just we'll write the capacitive reactive power. So this is the case is the capacitive reactive power. Case 2, when a VAC, that is the converter voltage, is smaller than voltage V, so current flows from AC system to converter. So here it is the system is the absorb reactive power. So definitely it is a inductive reactive power. So this is the two cases with this one. Now case number 3, when VAC is equal to V. So in this case, the reactive power, so here the current becomes 0. Current is equal to 0, and reactive power also 0, means there is no exchange of reactive. So this is the 3 cases with the help of this one. Now what would be the VI area of STATCOM? As the controllable var generation and absorption in the both sides, means it is a capacitive as well as inductive. So we can draw the IV characteristic in such a way that this is the, say this is the inductive side, and this is for the capacitive side. This is some voltage for the this one, as it is going to control in the both area. So say this is the maximum limit toward the inductive side. So this is inductive, reactive power, and here capacitive, reactive power. So as both side it is a controllable. So this area represent the controllable var generation, sorry, absorption, and whereas this area is the controllable var generation capacity. So this is the IV area or VI characteristic of STATCOM. Next, we can increase the, say, our understanding with the help of STATCOM along with energy compensation. Okay, so just I will try to now here, because we want some colored diagram. This is the system voltage. It is some reactance. It is the leakage reactance of coupling transformer. Now it is connected to the STATCOM. What is STATCOM? STATCOM is nothing but the switching converter type FACT device. So it is STATCOM. It is connected to the energy storage system. So it is the energy storage system. Storage. It is going to deliver some current, DC current, it is IDC, and the voltage across the energy storage system is VDC. So it is called as a DC terminal. DC terminal. Now it is a STATCOM. The output is AC. So let this voltage is VAC. The reactance is there, or reactance X is there. And now this is the current. It is IAC, and voltage of the system is V. So this is the case. Now here in the previous case, which we have explained, this part is not there, energy storage system. So it is either consuming the reactive power or delivering the reactive power. Now we try to understand with the help of this diagram. This is the say in this direction. As usual, we will take the reactive means and in this direction we will take the capacity. Okay, so let this is the VDC. This is VDC voltage, VDC, and here the current is there, or in the same way we can explain this is the current IDC. Whereas this is, we just make 4 quadrant of this circuit. for our understanding. So this is VDC. Under such condition, this is IDC, or sorry, VAC, voltage across this one is VAC. The current delivered by compensator IAC, it has two components. One is IQ and second is ID. So when the voltage, again we will take the part VAC, AC is greater than V. What is the condition? It generates reactive power Q, isn't it? So one may say that it supplies the reactive power. It supplies reactive power Q. Okay. So under such condition, it supplies the reactive power. Whereas if second case VAC is greater than V, okay. Okay, first we'll take the VAC. VAC is smaller than V. So what would be the case? It absorbs the reactive power. So here, or we can say that for that purpose, as long as your VDC and IDC in this direction as shown, so it's supplying the active power. So you can say that the active power supplies. So active supplies active power P. So in this quadrant, the reactive power and active power both are positive. Now with the same one, means the IDC is going to supply. So whereas the VAC is smaller than V, it's consumed or absorbed reactive power Q. So under such condition, it consumes the reactive power. So absorb reactive power, whereas the direction of DC current is same. So we can say that it supplies active power. Yes. So just try to understand. The energy storage system in such a way that VDC is the voltage across energy storage system and DC current is going to supply. This is a positive direction. The current is going to supply to the STATCOM. So in both cases, either the voltage is greater than the system voltage. So under such condition, it is similar to the synchronous motor overexcited. It is going to supply the reactive power. When the VAC is smaller than the supply voltage, then definitely it is going to consume the reactive power, and it is similar to the underexcited system. So here, both active and reactive power supplied by the STATCOM, whereas in this quadrant, with the fourth quadrant, the reactive power is going to absorb, whereas the active power is going to supply. Now the case is such that the current become opposite, means it is going to store. So it is the IDC. So this is the IDC is there. You can represent in the IDC. It is in the negative direction. Now take same case when the voltage is greater than the supply voltage in the third quadrant, whereas the current is opposite direction. So we can write here supplies reactive power, whereas it absorbs active power. So P is the active power, Q and P. Q is the reactive power, and P is the active power. Okay. Whereas in the third quadrant, where the voltage is smaller than the subsystem, so it absorbs the reactive power, whereas the DC current is opposite. So again, both are absorption. So it absorb the reactive power and absorb the active. So this is the operation of STATCOM along with energy storage system. So if there were no energy storage system, either it is going to supply or consume the reactive power, controllable reactive power, whereas some energy storage systems are there, then it also handle the active power, which is used to improve the transient stability and oscillation or avoid the oscillation into the system. So this is the some cases are there. Now we'll see some other operation of STATCOM with the help of some diagrams. So this is the area. This is entire area is there where the controllable reactive power is going to supply or consume. So in this direction, in this case, it is absorb the reactive power. This is the area, and it is for the supplies or generate. So either we are using absorption, and here is the generation. Okay. So next is the STATCOM in conjunction with the fixed capacitor. So this is the part which is the VI characteristic of STATCOM. Okay, so therefore this is the STATCOM. This is the maximum current in the capacitive side. This is the maximum current of STATCOM in the inductive side. Whereas because of the fixed capacitor, this VI characteristic this is the new VI characteristic which is shown by the some parallel lines are there. Okay. So whereas the ideal characteristic of STATCOM is this one, because the capacitor is connected, fixed capacitor. So because of this fixed capacitor, this controllable area is get increase in the generation side. Now same, if you replace capacitor by the inductor, say second diagram, here the inductor is there. So similarly, the STATCOM characteristic, this one is the STATCOM characteristic. Okay, this is the STATCOM characteristic which is shown earlier. This is the controllable VAR in the both side, inductive side as well as the capacitive side. But the fixed inductor is connected, so this is the additional control area is available for this one. Next, it may be combined with the help of thyristor switch capacitor, and this is the thyristor control reactor. So this is the control reactor, this is the switch capacitor along with the STATCOM. It is a entire circuit is the shunt compensation. So this is the ideal characteristic, or this is the characteristic of STATCOM, because it represents the STATCOM maximum STATCOM capacitive side. It is the inductive side, and now this area is because of the thyristor controlled reactor, and this area is the thyristor switch capacitor. So this is the something which is related to the STATCOM. So STATCOM may be with energy storage system or without energy storage system.